Imagine waking up to a headline that reads, NASA discovers Earth 2.0. Sounds incredible, right? A planet just like ours with oceans, breathable air, and maybe even life. Well, as exciting as that sounds, the truth is far from it. Despite the countless planets we've discovered, we haven't found a single one that we can truly call habitable. Today, we're going to cut through the hype and look at why none of the so-called Earth-like exoplanets are actually capable of sustaining life as we know it. If you're ready to separate fact from fiction, let's dive in. We will be going planet by planet to explain why each potentially habitable exoplanet is probably inhospitable, and afterward, we will go over some planets that actually have a better chance of being habitable. Let's start with the well-known Kepler-22b. Kepler-22b is in its star's habitable zone, meaning temperatures are right for liquid water. However, beyond that, it has no similarities to Earth and should have been removed from the list of potentially habitable exoplanets long ago. For one, we don't accurately know its mass. We only know it's less than 9 times the mass of Earth, but nothing more. We do know its radius, which is 2.3 times wider than Earth's. Rocky planets don't usually get that large, and with Kepler-22b's likely mass, there's really only one reasonable conclusion. Kepler-22b isn't a rocky planet. This means it probably doesn't even have a solid surface, and more closely resembles Neptune than Earth. There is a possibility that Kepler-22b could be a planet entirely covered in hundreds of miles of water, which could explain its low density. However, just because water might be present doesn't mean the planet is habitable. Oceans this deep are unlikely to be suitable environments for life. From what we know, life seems to require volcanic activity to get started, either through hydrothermal vents in the deep ocean or hot springs on land. Achieving these conditions is difficult when all the volcanoes are submerged beneath an ocean, with such high pressure that the bottom layers turn solid. This extreme pressure makes it nearly impossible for the necessary chemical interactions to occur, which are crucial for the emergence of life. So whatever Kepler-22b is, it's probably more like a smaller version of Neptune or an ocean planet with water too deep to support life. It's safe to conclude that despite having the right temperatures for life, Kepler-22b most likely doesn't have anything else that would make it habitable. This is crucial for understanding the rest of this video. Just because an exoplanet is in the habitable zone of its star doesn't mean it's actually habitable. The habitable zone only indicates that a planet within it could have the right temperatures for liquid water on its surface. It says nothing about the amount of water, its atmosphere, whether it has enough atmospheric pressure to support liquid water, its size, or any of the other key factors needed to make a planet truly habitable. From what we know so far, habitable planets are rare, extremely rare. Anyway, the next exoplanet on this list is Kepler-186f. At first glance, Kepler-186f looks a lot more promising than Kepler-22b. For one thing, it has a mass that's pretty close to Earth's at around 1.5 times Earth's mass, which means it's most likely a solid planet with a rocky surface. Out of all the planets I'm going to discuss today, Kepler-186f is one of the few with the best potential for habitability. However, it does have a significant drawback. Its equilibrium temperature sits at around 120 degrees, 85 Fahrenheit, which makes it colder than the average day on Mars. In fact, its temperature is roughly between what you'd expect on Mars and Jupiter. To be fair, we don't actually know Kepler-186f's real temperature,